Hello and welcome. My name is Boris Gebauer, and in the next few minutes I will show you how to create a 3-tier business application with TimeLine Developer. TimeLine Developer was designed as a rapid application development front-end to Visual Studio and automates the creation of rich user interface applications for WPF and HTML. Let's first have a look at a few features of TimeLine Developer apps. TimeLine Developer apps are 3-tier applications. They consist of 100% managed code, usually written in C#.NET. And they feature a modern WPF or HTML5 interface. The middleware is called the TimeLine Server. TimeLine Server offers several services that can be used by TimeLine Developer apps, such as the Dataset and Document Management Service, a JSON service for mobile devices, an SMTP and IMAP adapter for complete mail support of any TimeLine Developer application, a CalDAV service for bidirectional calendar functionality and integration with Outlook or other calendars, and an integrated web server to host the HTML applications created by TimeLine Developer. Let's now have a look at TimeLine Developer itself and create an application with it. We start TimeLine Developer and log into the database. You can use an existing database or create the database using TimeLine Developer. For this, TimeLine Developer features a designer called the Database Designer that allows you to have a look into the database, look at the data, and change the structure of the database by adding tables and fields or deleting tables and fields. Alongside with every table, you have a database repository that allows you to create comments to tables and fields and to also predefine controls that you will use for certain database fields. Primary keys as well as foreign keys and reference tables are being shown. And as said before, you can have a look at the data by just looking at Daten anzeigen to also modify the data or have a look into separate database tables. The table editor allows you to edit and change fields. Changes are being written into an SQL log that can be deployed on the productive database after you deploy your coding. Let's now start with a new project in TimeLine Developer, so we start at the IDE. First of all, before we create an application, we create a dataset. The dataset is the capsule with which the data is being carried from the database server to the client application. The dataset essentially is a capsule that contains several tables and hosts the data model of the business object. Creating a new dataset, we first specify the name. Let's make a customer master. That's the dataset designer. And the first thing we do is we add a table. The table name inside of the database can vary from the database. So let's call it a customer table. And now create the SQL statement for that customer table. For this, we select one of the tables or several tables joined together from the database. We can search for tables using the repository, and we can select fields from the database by clicking next to each field. Non-nullable fields are shown in bold, so when you want to update these fields, it's easier to find them and select them for your dataset. Let's also create a second table to create a little master detail example. So we added a contacts table that also should be updatable. Tables that should be updatable obviously also need to have the update statement set here. Now we got our dataset all laid out. Since we do not want to load all the data into our dataset, but only one customer and its reference contacts, we can specify retrieval arguments up here. As we already saw in the database designer, the path table we are using is having a compound primary key consisting of two segments, the field type and the field number, given here with the yellow little key. Inside of our dataset, we therefore specify type and number as retrieval arguments and add them to the where clause of the SQL statement. The same we do for the context table. We save the dataset, which will automatically create a typed dataset, which allows us later to address tables and fields strong typed with IntelliSense inside of the coding engine, and we test the dataset in the preview. For this, we manually specify the retrieval arguments and press the load button. The customer row in this case, since the primary key was identically specified, contains one row, whereas the context table in the dataset contains several rows with several contact persons. The name can be seen here. So that's our dataset. The dataset obviously can consist of as many tables as you wish, can be updatable or not updatable. If you want to update the table, specify the updatable table here in this parameter. Any change and any subsequent change to the dataset will automatically result in the regeneration of the typed dataset, which we will come back to later. Let's now create a little customer master project. So we add a new project inside of our Visual Studio project. And we now create the first user interface by adding a new module. Here you have the option of creating WPF modules as well as web modules. We first go with the WPF module. Any module consists of a window, a business object, and a dataset. We first specify the name for each of these objects. And we select our dataset that we already created. Now we have Window Designer opened, which allows us to design the window. We have two tab pages here already and a ribbon menu preset that can be added or changed and modified at any time. Inside of the Data tab, we see the structure of our dataset with the customer table and with the context table. On the Controls tab, we find all the controls that we will later place on our window. And behind the designer, we have the editors, the IDE for the VHO, the window handling object with all its different events, and the business object. Coding can be done in the integrated IDE or by pressing the Visual Studio button inside of Visual Studio. TimeLine Developer is fully compatible with Visual Studio. Let's first create the layout in a quick approach by just pulling the tables onto the canvas and selecting the fields. The same we do for the context table. We split the screen vertically into two segments, and the context we want to have not in a data panel, but in a data grid. We select only the important fields. And press OK. Now let's create a little button that allows us to retrieve the data. Retrieving the data we can do by using an event behind this MI retrieve button. So we start our first coding line. We enter the menu item retrieved event. And we use the MI retrieve button. As you can see, we have IntelliSense also in the integrated development environment. Now loading the data is actually easy because the retrieval arguments we specified in the dataset have already been generated into the typed dataset. So all we need to do is we call the business object. Inside of the business object we have the typed dataset called tset, and the retrieve method will already have our two arguments, type and number. For a simple case, we just manually edit these values. Later on we will do this via variables or input, and then we can start our module. First, in order to avoid the generic window for entering the retriever argument to open, we comment out the standard base event. Starting the module can directly be done by pressing the running man. The system will build and immediately start the module. Pressing the load button will now load the data of the customer with the number 90,000. Here in this field you already see the repository. The properties of this field, the combo box, are filled by information from the repository, where the field type can have the members customer, supplier, prospect or contact. Let's now add search functions to our module. We enter the designer and first add a new panel to our window. We drag the panel control onto our canvas and split the screen again vertically. We adjust the height of the grid. And then we add a combo box for the type and a search box that allows us to create a new search, a generic search that can be used not only in this module but also in other modules. We first drag the combo box, then the search box. We edit the labels. And since we know we already have a combo type ID, we select that combo type ID from the database repository. That will give us the items we've seen before on the screen. Now the search box contains a search definition. That search definition is reusable and can be defined in another designer. Let's edit a search definition for the table path, which is our customer table, and we call this customer search. Essentially, the core of a search definition is again an SQL statement, and we use the SQL designer we already know by selecting the path table and adding all the fields we want to have in our search. We press OK and specify which of the fields will return the primary key values and which of the fields are search and display fields. Usually search and display fields are the same. I just see that I forgot the type field, shouldn't forget that. So we add the type field. Here we go. Again, the combo typos are automatically identified by the information from the repository. We save the search, go back to the customer master, and add the customer search definition in the search definition ID property of the search box. The retrieve field in this case maps to the number field that is bound underneath that text box search. Now, in order to facilitate automatic loading, we bind the action property of the item changed event of that search box to an event that we find using the member picker that allows us to directly, via the action property, call functions from the business object, the window handling object, or access any of the dataset arguments. Let's now try our module. We select the type, and now we can call the search. See our generic grid. And then just select a customer or type in the customer name directly for loading. before the system will actually load the data, we have to set the binding path. And we can set the binding path to the retrieval arguments of the dataset. So we bind the combo box to the type argument, and the search box we bind to the number argument. That will effectively trigger the search, and you can either enter full text search directly in the number field, or you call the search function to retrieve the customer. Data in here is already editable and can be saved, so any changes to the data can already be saved by using the dataset. Let's now do a little more coding and add some initialized values or new rows to our custom master. Let's add new dataset information to the database. For this, we code the new button, MINew. We go back into the window handling object. And we'll now code the new event. Since we want to create a new row in our dataset, we first clear the data which is currently loaded by using the clear function. And then we create a new row using a variable that we call new customer. New customer can be populated by a method that the type dataset automatically contains when we generate the type dataset from your dataset definition. So we specify that we want to use the customer table inside of our dataset and add a new row to the customer table. That will create a variable new customer, which already contains all the fields that we've specified in the dataset. So we now initialize the values using the IntelliSense. Here you see the fields in the IntelliSense that we previously selected in the dataset. For the customer number, we need to retrieve the latest number from the database, so we use the embedded SQL method. That enables us to run directly SQL statements even if we are running the whole system over the web. If the database should return a null value, we can initialize with the default of 0 and add and increment the value by 1 to get the new customer number. Like we did here, we can initialize any field using the IntelliSense of the type dataset. Since I have a few not nullable fields, I have to first fill these values or initialize these values before I can save them into the database. After we've initialized all the values, we will add the row to the dataset. using the addRow method. This is also contained in the type dataset. When we are done, we synchronize the default view, i.e. the data panel, with the first row in the dataset. By moving to the first row in the dataset. After we've done that, we start our application and see whether it works. We press the new button and have the new number, the initialization of the customer type, and we can already save the data. To check whether the data was saved, we use the search function and find the data as we entered it before. So actually, without much coding, we've created a complete module with search functionality, update and save capabilities in TimeLine Developer. The last step is to add the module to the menu of the user, to the application module. And you can do this by adding it into the menu. From now on, everybody in the application can call this new module directly from the application content. Thank you very much for watching this video. I hope you liked it. Any questions you can always route to me via my mail address bgbauer@timeline.de. Thank you again for your time and have a nice day.